Um, we will start today to discuss and explain a very important topic, and that is telecommunications, the internet, and wireless technology. Let's go.
This chapter discusses the basic technologies used in networking and the internet. We will handle this topic from different perspectives. First, we will explain the basics and the main concepts regarding networking technology. Then we will discuss the main telecommunications transmission media used by networks and the type of networks. The third topic deals with the global internet and how internet and internet technologies work and how they support firms and especially in the area of e-business. The fourth topic handles the area of wireless networking and how it supports mobility in organization. And finally, we will explain how RFID technology supports firms today and support firms by using wireless sensor networks and which role IoT plays in this context. IoT is the short term for Internet of Things. Coming now to the fundamental question, what is a computer network? A computer network is simply two or more computers are connected to each other. As you can see here, a list of all basic components involved in a simple network. We will start first with the client computer, the term of client computer. A client computer is normally an average normal computer that for sure you have seen in firm before. And many workplaces are equipped with client computers. A client computer has the function to support employees to accomplish their day-to-day tasks, and it sends requests over the internet to another computer. That's why we call it a client computer. A server computer, in contrast, it is a powerful computer and hosted normally in a data center in an organization. It received requests from client computers and served them with responses. That's why we call it server computer. Very important computer server in a network is operating system server, network operating system server, which manage the network functions and coordinate the network activities. Network interfaces devices, they are attached to computers and allows computer to get into the internet. Hub and switches are central devices that connect all computer and forward data streams as packets from network member to another. Switches are more intelligent than hubs, since switches can filter data packets to the exact target computer. But hubs forwards the received packets to all other members in the network. I think for sure that every one of you has its own router at home with which you can get into the internet. It is a connection device that connects a firm to internet and another networks. This graphic illustrates the components of a simple network. While the network operating system NOS is shown here as the network server, note that depending on the type of the network operating system software, a server may also be designed to reside on a client computers. This slide shows additional components one might expect to find in the network of a large company that has many locations and thousands of employees. Note that many firms are connected by traditional landline telephone networks and using internet telephones that run on existing internal networks and the internet. Firm-wide corporate networks integrates all departments' local area network of an organization. This organization has its own web server to manage the websites. Websites could be provided for public or as intranet or extranet. An intranet connects employees to each other to share information, for example. When employees log on to their computer at the office, the first page they are likely to see is the intranet portal homepage. It may provide links to important companies' news, important documents, tools, and other resources that the employees need to accomplish their daily tasks. An extranet is a secured website and normally supported by CMS, a content management system that makes extranet available to a company's customer, vendors, or business partner, but not to the general public. There, there are also additional components like mobile wireless, video conferencing systems, telephone networks, and wireless cell phones. And all these devices and components will be explained in the following slides. This figure demonstrates the components of a large company's network. Please note the difference between the wireless LAN and the mobile Wi-Fi network. Wireless LAN allows wireless access within the firm's office, while mobile Wi-Fi network allows internet access to employees outside the office. The advantage of the telephone-based wireless system is that they don't require a Wi-Fi hotspot to work. And in fact, telephone-based wireless systems can connect users to the entire global internet through their telephone networks. As more and more communication networks become digital and based on internet technologies, it will become easier to integrate them.
Client-server computing is a distributed computing model in which applications, processing power, and resources are located within computers that are linked to one another through a network. These computers controlled by so-called network server computer. Network server computer sets rules of communication for network and provides every computer with an address so other computer can find it on the network. Computer in the network can be client or server computer. The client-server model describes a way to distribute tasks and services within a network. The tasks performed by applications that are divided into clients and server. The clients can request services from the server, and the server, which is hosted on another computer in the network, answers the requests with responses. Usually, a server can serve several clients at the same time. Describing a computer as a server or as a client, it depends on the role during the communication. I will give you a simple example for a client-server architecture. If you use a web browser
to access on the Amazon's websites in order to give an order for item or product. Your computer has here the role of a client computer that sends a request through your web browser to the server of Amazon's computer. Amazon's computer here takes the role of a server computer. At the Amazon side, web server application of Amazon process your request and sends a response to you in your web browser with a message about your order, that your order is received and currently in processing. But if Amazon application sends a request to a supplier application to order your item, in this case, the Amazon computer takes the role of a client computer, and the vendor computer take the role of a server computer. That explains why the computer role as a client or a server is exchangeable. Please note the difference between network server and server computer that serve responses to client computers. Client-server computing has largely replaced centralized mainframe computing, in which nearly all of the processing takes place on a central large mainframe computer. Internet is the best example for client-server architecture. It is the largest implementation of client-server computing.
The flow of information between requester as a client computer and receiver as a server computer takes place in the Internet and network mediums. Requests and responses sent across the network as messages that could contain business information like requests for customer purchase order or invoice from the vendor as response. To transport the data through the network, the packet switching method is used. Packet switching is the method of dividing digital messages into several small packets of data called packets and sends the packets along different communication paths as they become available in the network. The packets then are assembled once they arrive their endpoint. In the past, before the development of packet switching technique, computer in the network used telephone circuit to communicate with other computer in the network. In circuit switched networks, such as telephone systems, a complete point-to-point circuit is established first, and then communication can be conducted. These circuit switching techniques were expensive and wasted available communication capacities, since the circuit was maintained regardless of whether any data sent. In this figure, we see here a message sliced into three parts. We call them packets. Normally, each packet travels independently through different routes depending on the availability of the network channels at the runtime of transmission. Every packet is inscribed with identification number of the message that the packet belonged to and the packet number, and finally the endpoint address which the message sent to. Obviously, the packet landed at the destination at different times, and so in different order. Based on the packet's identification numbers, the message being then reassembled into the original message. In a network, there are typically many different types of hardware and software components that need to work together to transmit information and receive information. Different components in a network communicate with each other only by adhering to a common set of rules called protocols. In the past, many diverse, proprietary, and incompatible protocols often forced business firms to purchase computing and communications equipment from just a single vendor. But today, corporate networks are increasingly using a single common worldwide standard called Transmission Control Protocol over Internet Protocol, or short TCP/IP. This graphic illustrates the four layers of the reference model of TCP/IP. Note that what happens when a computer A sends a message to computer B. The data that computer A creates is transferred first within the computer from the application layer to subsequent layers in sequence. This means in downstream direction. In this process, data split into packets and information is added at each layer, ultimately translating the packets into a form that can be transferred over the network interface, namely bytes and bits 0 and 1. After traveling over the Internet interface, the packets are reassembled at the recipient computer side for use by the application layer of computer B. A modem is a device that translates digital signals into analog form and vice versa, so that computers can transmit data over analog networks, such telephone and cable networks. Note that digital signals are representation of the two binary digits, 0 and 1, and are represented logically as on and off electrical pulses. The word modem stands for modulator, demodulator, modem. This graphic shows the three main topology to implement in LANs. LAN stands for Local Area Network that connect computers and devices like printer in department or in another organization unit. In star topology, all devices on the network connect to a single hub, and all network traffic flow through this hub. The advantages of star topology can be seen as follows. Due to its centralized nature, the topology offers simplicity of operation. Adding or removing network nodes is easy and can be done without affecting the entire network. Because of the centralized structure, it's easy to detect faults in the network devices. Disadvantages are: network operation depends on the functioning of the central hub, since central hub failure leads to failure of the entire network. Also, the number of nodes that can be added depends on the capacity of the central hub. The setup cost is quite high. Coming now to the bus topology. In a bus topology, one station transmits signals which travel in both directions along a single transmission segment. All nodes on the network receive the same signals, and software installed on the clients enable each client to listen for messages addressed specially to it. The most advantages of bus topology are: it's easy to set up handle, and to implement. It best suited for small networks. It costs very less. The disadvantages are the cable length is limited. This limits the number of network nodes that can be connected. It's suitable for networks with low traffic. Each device on the network sees all data being transmitted, thus posing a security risk. Moving now to the ring topology. A ring topology connects network components in a closed loop. Messages pass from computer to computer in only one direction around this loop. The ring topology is normally found in older LANs using talking ring networking software. Advantages: a central server is not required for to manage this topology. The traffic is unidirectional and the data transmission is high speed. It's less costly than star topology. Coming now to the disadvantages. The failure of a single node in the network can cause the entire network to fail. And finally, the movement or changes made to network nodes affect the entire network's performance.
Coming now to the main terms definition related to transmission media. First, the term of twisted pair wire. Twisted pair wire is for voice and data communications, maximum recommended run of 100 meters. Coaxial cable. Coaxial cable which is capable of high-speed data transmission, currently used for cable TV and for networks with longer than 100 meters. Fiber optic cable. Fiber optic cable, it is a clear glass fiber transmitting data as pulses of light generated by lasers, useful for high-speed transmission of a large quantities of data, more expensive than other physical transmission media and harder to install, often used for network backbone. A network backbone connects multiple networks together, allowing them to communicate to each other. It's very important to note that twisted pair wire and coaxial cable normally used for local area networks, while fiberglass cables are used to connect networks to each other. Now we will introduce the basic terms of wireless transmission media. Wireless transmission media based on radio signals of various frequencies and includes both terrestrial and satellite microwave systems and cellular networks, used for long-distance wireless communication and Internet access. Broadcast radio. Broadcast radio is a wireless transmission medium that distributes radio signals through the air over long distances, such as between cities, regions, and countries, and also short distances, such as within an office or home, and support, for example, Bluetooth, Wi-Fi, and WiMAX communication technologies. Cellular radio is a form of broadcast radio that's used widely for mobile communications, especially wireless modems and cell phones. Microwaves are radio waves that provide a high-speed signal, signal transmission. Microwave transmission, often called fixed wireless, involves sending signals from one microwave station to another. A communication satellite is a space station that receives microwave signals from, from an Earth-based station and then strengthen, strengthen the signals and broadcast the signal back over a wide area to any number of Earth-based stations. The range coming now to bandwidth. What is bandwidth? The range of frequencies of a particular telecommunication channel is called bandwidth. The bandwidth is the difference between the highest and the lowest frequencies of a single channel. The greater the range of frequencies, the greater the bandwidth and the greater the channel's transmission capacity.
The two components of the term Internet, namely inter and net, indicate that the term is about the exchange of data between computers via telecommunication networks. The Internet can be characterized as a decentralized global computer network that is formed from a large number of interconnected individual networks in which communication between the individual computers takes place on the basis of Transmission Control Protocol, Internet Protocol, TCP/IP. Actually, no one owns the Internet, and it has no formal management. However, worldwide Internet policies are established by a number of professional organizations and government bodies, including the Internet Architecture Board, IAB, which helps to define the overall structure of the Internet, and the Internet Corporation for Assigned Names and Numbers, ICANN, which assigns IP addresses, and also the World Wide Web Consortium, W3C, which sets hypertext markup language and other programming standards for the web. Because it would be difficult for the Internet user to remember strings of 12 numbers, the domain name system, DNS, converts domain name to IP addresses. DNS server maintaining a database containing IP addresses mapped to their corresponding domain name. To access on the computer on the Internet, users need only to specify its domain name. DNS has hierarchical structure. At the top of DNS hierarchy is the root domain. The child domain of the root is called a top level domain, and the child domain of a top level domain is called a second level domain. We will explain more about the domain names hierarchy in the next slide. Coming now to the next problem and the solution for it. The Internet is running out of addresses. With only 4.3 billion possible IP addresses, the currently used IPv4 is no longer sufficient for the growing number of the Internet user worldwide. The new Internet Protocol, IPv6, which enable up to 346 trillion IP addresses. That is an incredible large number of 39 digits with up to 32 characters. IPv6 addresses are significantly longer than the previously used 12 digits of the IPv4 addresses. The DNS database has a tree structure. You can find information about a domain by following the pointer from the root domain through the subordinate domain's name levels. Each domain name corresponds to a node in the DNS hierarchy. The top-level domains are located directly below the root domain. There are two types: geographical, like .eg for Egypt or .de for Deutschland, Germany, or organizational, like .com or .net. A domain that is directly below the top-level domain is called a second-level domain. Let us consider the top-level domain com as example. The second-level domain google.com is located under the top-level domain .com. Here is some services that are supported by TCP IP reference model. If you remember, we have 4-layer application, transport, internet, and network interfaces. In the application layer, there are some protocol, and the most important one is HTTP, which is understand the data delivered from transport layer and convert it in the way that can be supported by web application and websites. So here there are some other application or protocols supported by the internet, like email protocols, chatting and instant messaging, telnet, FTP protocols, and of course World Wide Web for websites, and voice IPs to use it for calls and transportation of voices, and virtual private network VPN. It's very important to get secure channel or tunnel to get into local area network from home, for example, to use this protocol. Here we see an example for client-server computing model. And we see different nodes. I can account here client as one node, server, the second one, application server, database server, and back-end system, the database files, and sale, production, accounting, and HR. That is all databases of the database server. You can see here in the server that is directly connected to the internet, use normally different kind of protocols, application protocols. If you remember the TCP IP stack or reference model, which contains 4 layers: application layer, transport, internet, and network interface layers. All these layers converting the data by different protocols. And what you see here in this slide, there are all application protocols used to convert the data in the way that application can understand. For example, for the web, we use HTTP protocol to understand websites that's based on specific structure for HTML, and convert it to application, for example, web browser, to generate websites. That is a protocol. For email, there are also protocols to convert the data in the way that email application can understand and process the data. And the same principle for other application, for voice IP, for telnet, or for FTP to transfer the whole files over the internet from computer to another one. And we have also here application server, where the process of the application are running, and then they can processing the data received from the server, and probably to access on the database over database server, which hosts a database management system. And the response go back from database files to database server, and from database server to application server to the organization server, and then over the internet to the customer at home with the response. For example, your purchasing order is in processing, or to inform him that the delivery on the way, and you will get your delivery at specific time. That is an example about client-server computing. Voice over IP. Telephony over the internet no longer runs as usual over telephone lines, but over data networks. Here, the languages is translated into digital signals, and these are converted into IP packets, which are then translated back into speech at the recipient side. The Session Initiation Protocol, SIP, is used for this connection via the internet. This graphic illustrates how a virtual private network works. The rectangles A, B, C, and D represent different computers on the VPN. In a process called tunneling, packets of data are encrypted and wrapped inside IP packets. By adding this wrapper around a network message to hide its content, business firms create a private connection that travels through the public internet. We have here the most popular services on the internet, the web, and the main protocols enabling the web. The web is interlinked connection of websites, which are collection of web pages linked to a home page of an organization, for example. These pages are created using a text markup language called HTML and transmitted to users' web browser by HTTP protocol. Web pages addresses, URL, are composed of the domain name of the websites and the file location of the individual web pages. And these web pages normally are managed by so-called web server software, and the most popular one is Apache. People find information of interest on the web. Search engine is the primary method used, which today act as a major portal to the web. Imagine that Google received over 63,000 searches per second on any given day in 2019. The Shopping Pot is an online price comparison software tool which automatically searches the products of many different online stores to locate the most affordable rates for the customers. Generally, this shopping bot ranks items by prices and let buyer link directly to the website of an online shop site to actually buy their preferred product. With this figure, we will summarize how a Google search engine works. Basically, there are three main components or steps that are processed by any search engine. The first phase or step is indexing process. It's about creation and maintenance of index where information gathered about web documents and its data structure by using so-called or a subprogram called crawler. A web crawler or spider is a computer program that automatically searches the World Wide Web and analyzes websites. For example, scanning the website word by word and clustering the most frequent words, and also gathering information about the embedded hyperlinks to use them as a bridge to jump or to move to other websites and analyze them again, and so forth. That explains why it's called crawler or spider. Please note that indexing process runs all the time independently from any running user queries. The second process is the process to finding results and ranking them. And finally, preparation to output the results in the possible useful form for the end user by giving title of the results, short description about it, issue date, etc., etc. So moving now to the definitions or the basic definitions of the current standards in wireless networking. Bluetooth links up to 8 devices with a 10-meter area using low-power radio-based communication. Smartphones, computer, printers, and computing devices using Bluetooth to communicate with each other and even operate each other without direct user intervention. In most Wi-Fi communication, wireless devices communicate with a wired LAN using access points. The access point is a box consisting of radio receiver, transmitter, and antennas that links to a wired network, router, or hub. Please, I don't want from you to memorize all technical description. Rather to understand how use wireless technology in the environment of business and organization. This graphic shows the uses of Bluetooth for a PAN, personal area networks. Bluetooth connects wireless keyboards and mic to PCs or cell phones without wires. Note that one of the most important advantages of Bluetooth is that it has a low power requirement. In contrast to the wireless personal area network, wireless LANs have greater transmission power and ranges and generally offer higher data transmission rates. This graphic illustrates an 8211 wireless LAN operating in infrastructure mode that connects a small number of mobile devices to a larger wired LAN. Most wireless devices are client machines. The servers that the mobile client stations need to use are on the wired LAN. The access point controls the wireless stations and acts as a bridge between the main wired LAN and the wireless LAN. This means a bridge connects two LANs based on different technologies. The access point also controls the wireless stations. This slide introduces one of two wireless technologies having a major impact on business today. Radio frequency ID, short RFID. Walmart, for instance, uses RFID to manage inventory and supply chains. An RFID system consists of two devices, tags, or called also transponder, and reader devices. Tag, which is located on or in an object and contains an identifying code, and the reader for reading out this identifier. RFID transponders can be very small. The coupling is done by magnetic fields generated by the reader within a short range, or by using high-frequency radio waves. This not only to transmit data, but also to supply the tags or transponder with energy. Active tags or transponder have their own power supply to achieve greater ranges, but these are associated with higher costs. RFID support and automate many business processes, like automation of toll collection, tracking deliveries in supply chains, and in the logistic, and also in warehouse management, or to support replenishment in retail sectors like Walmart. RFID technology has two problems regarding cost and implementation. While the cost of RFID tags used to be too costly for widespread implementation, but today the cost is about 10 cents for a passive tag. So RFID is becoming more and more cost effective. Special hardware and software are needed to use RFID to filter, aggregate, and to prevent RFID data from overloading business network and system applications. Also, applications will need to be redesigned to accept massive volumes of frequently generated RFID data and to share those data with other applications. Major enterprise software vendors, including SAP and Oracle, now offer RFID-ready versions of their supply chain management application. This figure simply demonstrates what we explained before, how RFID works, starting from the tag. Here, as active tag, transmit information about its identification, and received by the reader. The reader processes the data and then pass the data to a business application to be used in a business process, for example, for supply chain management system, which is most fitted for using RFID technology. This slide introduces a second wireless technology that has major impact on business today. Wireless sensor networks, but in the context of IoT, Internet of Things. Note that wireless sensors are linked into an interconnected network that routes the data to a computer for analysis. With the Internet of Things, IoT, objects get clear identity and can communicate with one another. With Internet of Things, application can be automated and tasks can be carried out without intervention from outside. In general, the term Internet of Things is used to connect object or machine in an industrial environment via the Internet. Devices get unique identity in the network and are equipped with electronic intelligence. This enables them to communicate over the internet and perform tasks fully automatically. The intelligent devices are often referred to smart devices or called smart devices. In this figure, the lower level nodes and the higher level nodes at work in a wireless sensor network. Note that the server that receives data from the sensor acts here as a gateway based on internet technology in order to connect other remote servers. So, we are at the end of the lecture today. I hope you understood the stuff, but I think it's very hard for you to memorize all terminologies that we introduced. Try or please read the lecture in the book carefully. And if you have any questions, please send me per email or our TAs. We are willing to help you anytime. Good luck.